Hi, this is Miss Hobbs, and I'm going to walk you through how to do the rest of the problems on the review. You're going to have a test on Friday, so what I need you to do is make sure that your binders are out and that you've done your bell ringer. It's posted on the side of the board, and you're following along with me as we do this review. We have covered the first couple of questions on the review, so I'm going to scroll down to probably, let's talk about 6, and we'll go on from there on the review questions. So 6 is a true or false. The change in momentum of the object is the same as the impulse applied. And that is actually true. In the upper right-hand corner of the board where it says save, you've got a couple of formulas that are there. And the change in momentum is delta P, and that is equal to the change in impulse. So impulse is force times time. Let's see if it writes for me. Nope, it's not going to write for me. Okay, impulse is force times time, and the change in momentum is mass times the final velocity minus mass times the initial velocity. So the change in momentum, the force applied over an amount of time, is the same as the mass and the change in velocity that the mass goes through. Okay? So 7 says a kid on a skateboard has a medicine ball. It's a heavy ball used in weightlifting class. He throws the medicine ball forwards and as a result moves backwards. Who has the greater velocity? Well, the kid's probably around 50 pounds and the medicine ball is probably at max 10 pounds. So if the medicine ball goes to the right and the kid goes to the left, the medicine ball weighs less and the kid weighs more. So the medicine ball weighs less, then what's going to happen is it's going to have a faster speed, while the kid may weigh more, and so it's going to have a slower speed. Okay? So the next question is two kids are on skateboards facing each other. They push off each other at the same time. Kid 2 ends up going faster than kid 1. What can we conclude about the mass? So what's happening here is energy conservation is what's happening here. So there are equal and opposite forces taking place. Oops, I moved it. I'm not sure why. Equal and opposite forces taking place. So as equal and opposite forces take place, when one kid goes that way, the other kid is going to go that way. And since it's equal and opposite, if one kid has greater mass, he's going to have a smaller velocity, while the other kid who has a lighter mass is going to have a shorter velocity. So on number 9, it says some students are playing pool. The pool cue hits the balls. Is it an elastic or inelastic collision? And you guys should probably take home and look through your foldables that have the cuts of the 8 vocabulary definition words. You need to know those. But elastic means that kinetic energy is conserved, while inelastic means that kinetic energy is lost. So an example of an elastic collision is where things are continually bouncing and moving around. Example of that would be the Energy Skate Park lab, where we had the fictional pool table and the balls kept moving and moving and moving and moving and they didn't stop. An example of an inelastic collision would be a car crash, because the car and people's bodies absorb all of that energy, and that energy doesn't stay into the system. It kind of gets lost through transitional forces. So a pool cue hitting the balls is going to be an elastic collision, while a car crash would be an example of an inelastic collision. Okay? So the next one is you're going to have to write down the words while I'm reading through and talking through, and then maybe Mrs. Urban can help you write it down on the board for this one. It says a bungee jumper is standing on a bridge. The bridge is 20 meters tall, and the jumper has a mass of 40 kg. What is the jumper's potential energy? Show your work below. So what's happening here is we need to find out the formula, and the formula that we're looking for is potential energy. And you can see E sub P, that stands for potential energy. And we've got mass times the acceleration due to gravity times the height. So what we're going to do is we're going to need to identify the mass, the acceleration due to gravity, and the height. Okay. So the unit for mass is 40 kg, so go ahead and underline 40 kg. The height is 20 meters tall, and we want to know what the potential energy is, and we need to remember that the acceleration due to gravity is 9.8. So you're going to take 20 meters times 9.8 meters per second squared times 40 kg in order to answer this question. You're going to multiply them out, and that's going to give you the answer. So 20 times 40 times 9.8, and the unit for potential energy is going to be in joules. All right, number 10. A motorcycle and a rider have a mass of 130 kg. They coast down a ramp. They don't use the engine, so there's no additional energy. At the very bottom of the ramp, they're traveling at 5 meters per second. What is the kinetic energy of the motorcycle ride? Show your work below. So what we need to do is we need to find the formula that tells us kinetic energy. And you'll see something that says E sub K, and that's the formula for kinetic energy. And what you're going to do is you're going to take 1/2 times the mass times the velocity squared, and that's going to get you your kinetic energy. So let's think about our units. The unit for mass is going to be 130 kg, so go ahead and underline that. And the unit for velocity is 5 meters per second. So you're going to take 0.5 times 130 times 5 times 5 to show your answer. And I'll give you a second. Why don't you pause the video and you can calculate that. And the unit will also be in joules. So number 11 says, using the kinetic energy from the above problem, how tall approximately was the ramp that they started from? The acceleration due to gravity is 9.8 meters per second. So go ahead and show your work below. And we want to know, what we got to do here is we were calculated the kinetic energy in 10, right? Well, we need to know what the potential energy is. Well, the thing is that the maximum amount of kinetic energy is the same as the maximum amount of potential energy. So we're going to use the kinetic energy from the top part to substitute for our potential energy. So our potential energy formula is mass times the acceleration due to gravity times the height. So we're going to put the answer that we found for 10 and have that equal to the mass, which is still 130, times the acceleration due to gravity, which is 9.8 meters per second squared, times our unknown height. And once you do that, you solve algebraically. And the unit is going to be in joules because it's kinetic energy. And I'd suggest pausing the video and working that out below. Okay, number 12. A skater is traveling down a ramp at a skate park. His potential energy is 550 joules. His kinetic energy is 346 joules. What is the total energy in the system? Well, to find the total energy in the system, all you do is add potential energy to kinetic energy. So all you're going to write down is KE, or K sub P plus, E sub K plus E sub P is equal to ET, or energy total. So you're going to take 550 joules plus 346 joules, and that's going to equal the total energy in the system. And I'll give you a moment to pause and calculate that. A vulture is perched on a cliff ready to fly. Is this a case of potential or kinetic energy? Since it's perched and it's going to be moving, but it's not moving yet, it's a situation of potential energy, because the vulture could fall, and that would be an example of kinetic energy where it's actually moving. But it's right now, all of its energy is based on position. The next question says, a kid is spinning in a circle in the same place. Is this a case of potential or kinetic energy? It's a case of kinetic energy because it's energy of motion. Next, 15, we are all magically able to set up a skate park in deep space, the moon, Earth, and Jupiter. The ramp dimensions stay the same as well as the rider's mass. Are the potential energies the same in each place? Why or why not? Let's think about it for a second. I'll pause. Maybe answer it. And the answer is the potential energies are not the same. And the reason why is the accelerations due to gravity are different. The moon has a much smaller acceleration due to gravity than the Earth, and Jupiter has a much greater acceleration due to gravity. It's like 26 point something compared to 9.8 something. And in deep space, there is no acceleration due to gravity. And so an object just stays, keeps on, keeping on, continues in motion. So 16, by changing the location in the solar system, what factor that affects energy did we change? We changed the acceleration due to gravity. 17, what role does friction play when we talk about the conversion of potential to kinetic energy? Well, when something's got potential energy, it's got all the energy it has. But when it starts moving, kinetic energy, things like air resistance and friction, you lose some energy of the potential energy to air resistance and friction. So it doesn't result in the final amount of kinetic energy. So friction, you lose energy and it gets transformed from potential energy to thermal energy, which is heat. In the second lab, we released two cars from the same point and they went opposite directions. The kinetic energy in the system was the cars that were moving. 19, the Car Safety Commission is doing airbag testing. They need to change the impulse of a person in the collision without killing the person. What factors do they need to change in the airbag? Well, they need to increase the amount of time that the airbag is deployed so that can decrease the amount of force. I'll say that again so you can write it down. They can decrease the amount of time, increase the amount of time that the airbag is deployed, so that will decrease the amount of force. Number 20, in a closed system, the amount of energy can change. That is false. In a closed system, everything is the same. 21, true or false, temperature is a measure of thermal energy in the system. That is true. And 22, true or false, when a tennis ball and a tennis racket collide, the racket hitting the ball and the ball hitting racket are different forces. That is false, because for every action, there is an equal and opposite reaction. You will also need to know what the units for things are. So mass, you're going to know kg. Velocity is meters per second. Force is newtons. Time is seconds. Momentum is kg, meters per second. Gravity is meters per second squared, and distance is in meters. So you need to, any variables that are listed on the formula sheet there, you need to know what those units are. Work can be in Newton meters, or it can also be in joules, and energy will be in joules. So you need to know those units. Okay? If there is time left, what you need to be doing is you need to be going through your entire unit, quizzing yourself on the vocabulary terms with the foldables. You need to be going through your notes and reading through your notes again. You can even quiz each other. You can even ask questions about how to do certain problems and practice with certain problems. This test is really important and you need to do very well on it. So if you have any questions, try and use your friends as help. Yeah, and I will be here Friday morning if you do have any questions. So thanks for listening, and make sure to give me feedback on whether this worked or not for you as a way of learning how to do things. All right, thank you for your time.